And now we'll continue with the equivalent circuit model for JFET and MOSFET. So even though we have studied the drain characteristics and transfer characteristics of JFET and MOSFET, whenever you are going to use JFET and MOSFET inside an electronic circuit, we need to have a mathematical model, just like how we have a H parameter model or hybrid pi model for a transistor. We need to have one such model for JFET and MOSFET when you are going to use this as an amplifier. Okay, so first we will see about what is the small signal equivalent circuit. The small signal equivalent circuit is mainly used in low frequencies. Whenever the transistor is used as an amplifier, I'll be going for small signal equivalent circuit, which is essentially a low frequency model, which is mainly used for transistors in amplifiers, you see here. And after studying the small signal equivalent circuit, we'll also introduce what is called as the high frequency effects in the transistor using capacitors. So finally, we will say what is the cutoff frequency and the figure of merit for both JFET and MOSFET. So similar to how we have analyzed the equivalent circuit for transistor, the same way here also first we will study the low frequency model for the JFET and MOSFET, and then we'll slowly introduce the high frequency effects in the equivalent circuit. And you know that in high frequency the capacitors will come into picture. So we have seen in the transistor itself, hybrid in the H parameter model we will not have any capacitance, but in hybrid pi model you will have three capacitance which will be coming into picture, right? Same way here also in low frequency low signal equivalent model you will not have the effect of capacitors because the amplifier is acting at a low frequency. When we are going to increase the frequency of operation, we are going to see how the equivalent circuit is going to change for the JFET and MOSFET. So the high frequency equivalent circuit will help us to determine what is the maximum frequency of operation of your transistor, and also the figure which is going to be the figure of merit for JFET and MOSFET.